And my guest is Chris Wheeler, and Chris is with Trimble Navigation. Trimble, I recall way back when, used to be a GPS company. Not so much anymore. So where is Trimble now, and why are you here at AUVSI?
Well, Trimble's got a lot of different applications they do. The majority of them are based primarily on GNSS applications, but what we really do is we provide that precision location and orientation information into a lot of different applications. So if you think about our traditional verticals that we've been in, what we do is we do things such as geospatial, agricultural, construction control. Realistically, at the end of the day, what we're doing is we're providing really precise information in regards to where the blade is for a bulldozer, where the piece of equipment is for automated agricultural control, or in geospatial, obviously, survey quality information. My group in specific, Integrated Technologies, and then one of our sister groups within Trimble, Applanix, are using that information to work with OEMs and ODMs in the UAV space in order to develop the basis for precision location information. Integrated Technology specifically does the location information, while Applanix does the post-processing of information where you take visual information, process it for using for mapping and scanning type information or LiDAR applications.
So when you look at some of the aircraft that are here at AUVSI, how do you integrate what it is that you do with some of these aircraft? And I know there's a lot of interest in the agricultural market, for instance, for being able to precision track crops and do those things. So where does what it is that you do integrate in with the hardware?
So there's a couple different pieces that we do. When you think about it, a lot of applications, open field, lots of clear sky, you could use a very low level GPS chip, kind of typical like you'd see in your guidance for your car or in your phone. And you get 3-meter accuracy. You're not too worried about running into things. You're not worried about going too high, too low. But what ends up happening is for a lot of the applications for what we're trying to get to for tracking, you run into harsh environments where you may lose tracking. So you need a solution that's actually going to allow you to continue to have guidance when you're blocked. Thinking of something as simple as a tree or maybe a metal trailer that's out on the site that may have moved and caused interference, so you get multipathing. You also have some things that happen in regards to the actual applications. So if you think about something going out and taking a photograph, and I'm going to take a picture of a set of ground, let's say it's 100 acres. I may have to take 1,000 pictures to cover that 100 acres. What happens though is you can't just take one picture and then magically line those two pieces up together. You have an overlap. And when you're using things like that imprecise type of precision information, what happens is the information has to overlap quite a bit in order to get those visual reference points. That creates a couple things. One is a lot more data you have to gather in order to do it. Even though your flight time of your actual bird stays the same, the amount of time you have to have it up in the air overall is increased dramatically because that overlap creates it. If you have that information and you can actually include that into your solution, what you do is the overlap shrinks. And as the overlap shrinks, you get more coverage per flight. You get the same amount of flight time, but more coverage per flight. You can take less photos, you get a higher level of accuracy in your overall solution, and more importantly, when you're doing all that post-processing type application, you have all this geo-reference and geo-tagged information that's easier to navigate and put to use.
So take us through a common scenario. And I think you kind of just basically did that, but let's look at something a little bit more specific as to what it is that your software does.
Okay, so when you think about us, we still have a very specific hardware component of what we do today. So what we're really providing is the precision location information today through a hardware solution. So let's imagine that you're talking about kind of the future of autonomous cars. Okay. Right? I want to go and I want to drive my car. Well, today, if I were to try to do that with traditional GPS in your phone, I could get it down the middle of a road reasonably well, but you know how like you occasionally drive on a frontage road and the GPS jumps over to the frontage road? Well, the reality is because the accuracy is larger than my arms are right now in a lot of cases because of interference. What we're doing is using correction sources that are ground-based or terrestrial-based, and we're allowing to make that much more precise. So now we're actually moving to where we use satellite-based corrections. So we have local base stations, the satellites are sending that correction source to you. Well, now we're talking in centimeters. And so when you're talking centimeters, that puts you in a lot more precise location. If I have the known location of where I'm mounted on the car and I have 2 antennas, now I actually can very specifically put you into a spot and I can drive you through at 60 miles an hour through a safe location. Now there are real things that move. There's There's animals that might run across the road, you know, birds that might come down out of the sky, other idiot drivers that might pull you over that might make you upset. So there's other sensors that you have to do. The secret is being able to get that precision information, because that provides a lot of information. I know exactly where I am. I can relay that information to a group of vehicles around me. Not only that, you see some of the technology now where we're passing things to the second car in front of us. Now I know exactly where I am. Well, not only are we doing that, we're doing IMU or MEMS, and we're getting the velocity, the vectors that are happening. I can actually transfer how fast I'm braking to the car 2 rows in front of me. Not only do you know where I am, but you know how quick I'm stopping. I get information about how quick my car can stop. A car has a wreck because there's a rainstorm that hit half a mile in front of us and the roads become slick. The cars now can automatically adjust because they're getting that information, because we know exactly where we are too. The secret's going to be is not where we are and what the things we're doing today. It's that integration of the sensors along with that precision location for indoor-outdoor navigation. Because as soon as I go in a tunnel, everything changes. And that's some of the stuff that we're looking at of what type of sensor technology can we integrate into our precision location solution that allows you to navigate through tunnels. You drive out on I-70 out where we're from in Colorado, you got a 1.5 mile tunnel you're going through. You've got to have a solution that can continue to navigate for that time. And we've got some solutions that using those MEMS that allow for calibration for those type of applications, whether or not it be autonomous vehicles, a UAV that's flying under a tree or in, you know, kind of urban canyons of tall buildings, that can take one solution, has that, goes out of coverage where it's no longer good, and it can continue to operate.
It's interesting because I was about to come back to the UAV part of it. When you talk about the ability to talk to the car in front of you, can you also then have that solution that talks to the other aircraft as well, so that your sense and avoid becomes, I know who you are, what you are, where you are, and I can stay away from you.
Yeah, and one of the nice things about my group in particular is we are a portion of the supply chain for a lot of our partners. What happens is we have full solutions. I mean, our verticals sell full solutions. You see them in all those different industries. But what we can do is, if you've got your communications figured out, we don't need to do that. We can do just the precision location. That, quite honestly, is where we provide the most value. If you don't have your communications pulled out, we've got groups within Trimble that can actually help you with you, or partner you with the right people in order to go do that, so we can put that information together. If you need software and post-processing, that's, you know, Planex's wheelhouse. That's where they can come in and provide the most value to you. And you can kind of pick and choose. And what we're trying to do is trying to help people accelerate their time into the market. And in the UAV space, that's great. One of the things that we're doing now that you may or not have heard of is we've actually come out with what's called soft GNSS. And so today we have the antenna and we have the board. What we've done was we've been able to take the code that actually resides on those boards and pull it out. And it actually can run on an Android-based platform. And so what happens is you no longer have to have that separate board. Well, it removes a lot of costs because most people already have an Android phone. Whether or not they're doing a survey, they're using an Android tablet to go out and do things. We're looking at the ability to integrate that into other solutions potentially, which is some things we can talk about. But at the end of the day, what that does is it reduces a lot of the weight for the UAV market, and it still at the same time provides you that centimeter type accuracy that you look at from an RTK type solution. It performs in those open sky environments where a lot of UAV happens, performs just as well as other RTK solutions.
Where does that then assist in the integration of UAVs into the national airspace?
So there's a couple things that it does. If you think about one, most people are running things off their tablets. So their tablet already has a lot of the mapping information that's in it, and they're keeping the smarts off their UAV and they're letting the tablet manage a lot of the smarts. Well, all that georeferencing stuff that's now relying on this less accurate GPS that's built into their phones or their tablets, we can replace that with really, really high accuracy precision information. Well, that starts to limit. So if I want to go and I want to do something that's close to a quarantined area, and right now I'm really flying 200 meters off because I'm just not sure, I can get a heck of a lot closer. If I want to operate a piece of autonomous robotic controlled equipment and there's a period of protected nature grasslands or something like that, well, instead of having to be 30 meters off, now I can be a meter off, or I can be even potentially closer, as long as I'm seeing the accuracy information come through. And what it does is it literally replaces that GPS engine in your tablet with our engine that allows you to actually run this higher accuracy information. And you're getting the information directly from the UAV, the drone, back to your tablet.
Well, Chris, it's fascinating, and I'd love to come by your booth and kind of see how it get a little bit of a representation of it. But we are out of time, so
no problem.
I really appreciate you taking time to come over and speak with us about Trimble, and we hope to see a lot more of you in the future.
Yeah, absolutely, pleasure.
Great. Thank you very much, Chris.
Thank you.
Aero-News Network's coverage of the Association for Unmanned Vehicle Systems International's Exponential 2017, live from Dallas, Texas, is brought to you in part by the following sponsors.
Let Patrick Neal and Associates provide the legal expertise needed to navigate the commercial UAS industry. Whether it be waivers, exemptions, operational plans, or other issues, we can provide the guidance you need to keep flying and building your successful UAS operation. www.droneattorneys.us.
In collaboration with NASC, introducing Sonix Aerospace, bringing you the Taros Group 4 UAS, the redesigned Tiger Shark Block 4, and the Subsonics Twin Jet UAS, all derived from flight-proven manned systems, not concepts, real aircraft. More at sonixaerospace.com.
Continental Motors Group. Manned and unmanned, Continental has been a pivotal part of aviation and aerospace history and wants to be a part of your mission. Gas or diesel, certified or experimental, Continental is investing in your future. www.continentalmotors.aero